Hello, my name is Greg Welch. I'm a professor and the Florida Hospital Endowed Chair in Healthcare Simulation at the University of Central Florida. My primary appointment is in the College of Nursing. I also have appointments in the Department of Computer Science and in the Institute for Simulation and Training. I'm an unusual faculty member in nursing in that I'm not a nurse. I'm actually a computer scientist and an engineer. Before I begin, I'd like to acknowledge collaborators on this particular work. I'd like to talk about my vision for physical virtual allocentric experiences in two parts. To begin with, I'd like to talk about the physical virtual aspects of the idea. We're all generally familiar with medical mannequins. While they have many benefits, they're generally unable to convey facial expressions, emotions, to dynamically change race and gender, or to convey visual symptoms such as wounds that are changing as you touch them, or wounds that are bleeding, for example, so dynamic aspects of wounds. Virtual patients, on the other hand, are, of course, very flexible. You can display anything that the computer programmer can program. However, they are, of course, flat. Approximately 5 years ago, some colleagues and I had the idea to create what we call physical virtual patients. The idea is to use projected imagery onto shells that are the shape of humans and to provide other effects such as temperature and sounds, as I explain next. Here's an early example of a full adult prototype. On the top, you can see the interchangeable human-shaped rear projection shells. These are the surfaces that are exposed to the healthcare provider. Underneath or inside the bed, we have infrared cameras and lights that can sense where somebody is touching. We are able to change body temperature throughout. So, for example, cold extremities or warm forehead. And we can provide audio sounds such as breathing or digestive sounds, and of course pulse all over the surface of the body at varying amplitudes. We more recently moved to ahead just to focus on more precise touch sensing and automated touch sensing in a tight integrated loop with computer graphics. So as shown here, one can actually reach out and pull down the lip of the patient or pull down on the eyelid to do, for example, a diagnosis for stroke, for example. We have since developed a prototype that is a pediatric version. And we did this for two reasons. One, so that it was more transportable, and two, because we had interested partners from the Florida Hospital for Children to look into pediatric scenarios. We've done quite a few experiments with the various prototypes that we have in hand. I won't dwell on them here, but I'll point out the last bullet here, the planned scenarios that we're going to explore with Florida Hospital for Children. We're very excited about that. They'll be coming up in the spring. So now I'd like to talk about the second aspect of the vision, which is the allocentric aspect. To begin with, I want to mention the notion of social influence. This is a concept in social psychology which has to do with how much the other being is able to influence us. So in this case, we would talk about the patient. How much does the patient, or the simulated patient in particular, affect us? And it has to do with the realism of the behavior, the appearance, and all sorts of aspects of the patient. And there are various measures that social psychologists use to estimate how much that being can influence us. So research has shown that there's a tremendous power in those virtual humans or those other beings being aware of us and acting in ways that represent their awareness of us and exhibiting awareness of us. So we're actually adding automated awareness to our physical virtual patients at this point in time. We're adding sensors around the patient to detect people and sounds. And we're distributing these sensors around to extend the awareness in an allocentric sense away from the patient. And the final vision here is for large area team training using these distributed allocentric sensors. Thank you.